Hello everybody. I will show you examples how BIM can and has been used for promoting site safety. I'll start with BIM-based 3D site layout planning, which is currently the most common way of using BIM for construction safety. The other examples are related to BIM-based fall protection planning, to BIM-based construction workflow visualizations, and the last cases are more like examples of the future possibilities of BIM. All these areas which I'm familiar with are at the same time examples of results got in research and development projects and examples of use of BIM in the industry. My first example of BIM-based site layout plan is a test trial made at VTT in our first BIM and safety related research project. In this case, we made a BIM-based site layout plan using a completed residential building project as a case example. On the right you can see the original 2D site plan which the contractor had used in the project. And on the left, the corresponding 3D plan made as a test trial and demonstration using ArchiCAD 11 modeling software. Very soon after the demonstration, we carried out a pilot together with Skanska Finland, and in that 3D site plan was done at VTT for an ongoing industrial building project. Basically, the modeling tools were the same, but new BIM objects representing site equipment and material storage areas were needed. And new kind of visualizations were tested based on special needs of the project. In this view you can see drive road for emergency vehicles highlighted with pink color. This was meant to underline that this path must be kept free throughout the construction project. However, this visualization representing risk areas on site in case of two different collapse situations was even more important and useful, since it's not possible to present and efficiently analyze the same thing in 2D. That's because the geometry of the risk area is so complicated. And I think the proof of the usefulness is that this kind of visualizations has been used later again in few other projects in Finland. My third site plan example has been created using Tekla Structures modeling software. Tekla was selected for the test trial since it provides more developed and flexible construction progress visualization tools than architectural software do, making more dynamic site planning and site status visualizations possible. We thought also that site progress simulations should be based on structural model, since that's where the building parts from which the building is to be built are presented. And the last example is a BIM-based site plan made by a Finnish contractor NCC using SketchUp as the modeling tool. As many of you may know, that's an easy to use and not too expensive tool either. But more importantly, I think this shows that the same kind of idea of visual 3D site plan can be put into practice using various BIM-based software, and one can select the tool which he or she prefer. However, I think the selection of the modeling tool should be based on how and by whom the resulting model is aimed to be used. Another clear area for using BIM for improving safety is fall protection planning. In Finland, both site layout plan and fall protection plan are required in all projects by authorities. And in the figure on the right, you can see quite a good example of a traditional safety plan where different guardrail types has been marked into a 2D plan by different colors. And on the left you can see an example of a detailed BIM-based fall protection plan made by ETT on behalf of a research project using project's structural model as basis and Tekla structures as the tool for safety modeling. This case project was an ongoing construction project and modeling was based on the information got from the site manager concerning fall prevention solutions they aimed to use in this project. This is an example of remarks they made when we presented the model-based plan to the site staff on the building site. In this case, they noticed that the distance between posts for this railing type would become too long since there is a big hole and the whole cover on the same line. And finally, they decided to use a different kind of posts on this edge. My second example of BIM-based fall protection plan is a quite new industry example. Modeling tools and the principles are the same as in the previous example, but this is made by Skanska in their residential building project in Finland. As you can see, safety modeling has been carried out covering the whole building. And in this closer view, you can see status in the model on a specific phase of frame construction. Planning has been carried out carefully, modeling all needed different guardrail types on all the edges so that the fall from height is prevented. And this other close view to the same model shows detailed BIM-based planning in staircases. This is already a normal procedure in Skanska Finland, but in general I think quite rare still in practice. And one reason for that is lack of suitable and easy to use tools for modeling. Third area where BIM can be used for safety is different kind of 4D construction work order planning and visualizations, including safety aspect. And my industry example is related to wall demolition work. On the left you can see the traditional 2D plan made by the contractor, presenting the wall demolition pieces and the sequences. And on the right the corresponding BIM-based plan, including the same parts in 3D, but instead of written numbers, the order was visualized as a simulation showing the process step by step so that the part being demolished was highlighted by pink color and after that hidden in the model view. This model view is from the first visualization test trial that was done for the lower part of the wall. Later on, the upper part of the same wall was demolished and another work order visualization was prepared for comparing two alternative sequences. First you will see the BIM-based visualization for option A. It starts from the top of the wall. The part being demolished is highlighted by pink color and is hidden after that in the model view. The visualization proceeds piece by piece in a specific order defined by the project staff, but in this demonstration I skip few phases to speed up a little bit. The same structural model was used to make visualization corresponding to the option B. Just the order, which is defined by Tekla's task manager, is different. In this option, demolition work is starting from the bottom of the wall and proceeds again piece by piece in the order defined by the project staff. These two visualizations were used on site when the project team discussed and planned how to conduct the work in a good and safe way. And both visualizations end to this kind of situation. I'll finish with two examples of future possibilities related to use of BIM for safety. Last year we carried out research cooperation involving Georgia Tech from US and VTT, Skanska and Tekla from Finland, and we tested automated BIM-based safety checking and planning using data from a Finnish construction project. We used Georgia Tech's prototype tool and Tekla structural model of that project to test and evaluate possibilities and development needs of automated planning. This test trial showed us that the prototype can create a rough fall prevention plan automatically and fast based on a BIM-based 4D construction schedule, and the resulting fall protection plan can be flexibly corrected by a safety specialist. I would say that the tool and automating safety modeling procedures really own potential, but further development is needed before the tool can be used in real projects by construction professionals. Another clear possible direction is use of mobile safety data, as the use of mobile devices is rapidly increasing on construction sites. In this Finnish case building project, iPads has been used for weekly safety level measurement and filing safety observations, as shown in the figure on the right. The contractor Skanska has had a kind of BIM stand there also, which is in practice a computer with a big touch screen display, providing opportunity for site staff to view models at field anytime. I think that in the future, mobile devices such as iPads will be used for viewing BIM-based safety plans as well. For example, to check what kind of fall protection is planned to be used in a certain point of the slab edge. Thank you very much for your interest.